All right, so if we look, question 20 is a combustion analysis problem. If you notice in the question, it tells you the sample is 0.0989, right? That's the mass. They give you CO2 like they normally do in a combustion analysis, and they give you water. First thing you're going to do is you take CO2 and you convert it to grams of carbon. We've done this in class multiple times. So you take the grams of carbon, divide by its molar mass, you get moles, 1-to-1 ratio, and then when you run the grid, you should get that many grams of carbon. So taking CO2, converting it to carbon is your first step. Second step in a combustion analysis problem is you take the water, you take the 0.1194 grams of water, 18 grams is equal to 1 mole, 1 mole of water is equal to 2 moles of H, because the formula is H2O. So inside there, one of those has two H's, so that's where the 1 to 2 comes from. 1 mole of H is equal to 1.01 grams of hydrogen. And then I get 0.031327 grams of hydrogen. All you do to find the oxygen percentage is you're going to take the sample. So you go 0.0989 minus 0.05891 minus 0.01327. Subtract out the carbon and the hydrogen. You're going to get just the grams of oxygen. And if you want to know the percentage of a mass, you would take whatever the grams of oxygen is going to be when you do that over the sample size, which is 0.0989 times 100, and I believe that comes out to be, if I am correct, well, let me see what it says here. The answer you should get is 26.9. So you should end up with 26.9 if you do that correctly. Next question is a limiting reactant problem. Actually, no, it's a percent yield. If you look, they're giving me 11.3 grams of ethanol. Ethanol is going to be right there. That tells me that has to go, if it's a left-hand side, it has to go on a grid. They give me 3.48 grams of PCl3. That's on the left side of the equation as well. Those are going to be in the grids. Those go grid style. The actual yield of C2H5Cl2 is on the right-hand side. That value goes to the top of the percent yield formula. So what you're going to do is you take the 1.24, that's what's actually produced. So you're going to run the grids just like we would have done in class. You take the molar mass. This is 46 into 1 equals 1 mole, 3-to-3 ratio from the equation, and then the molar mass of C2H5Cl. I get 15.8 at the end of this grid. If I take 3.18, divide by the molar mass, I get a mole. It's a 1-to-3 ratio, 1-to-3, and the molar mass at the end is 1 is moles equal to 64.5. When I run both grids, that's what I get at the bottom of the grid. I get 4.90. This is my excess. That's my excess right there. So that's what is left over. My limiting reactant is PCl3, but that's not what they're really asking me in this question, but I could ask that on the test. They want the percent yield. The actual, or the theoretical value is always a smaller number at the end of the grid. Put it on the bottom times 100, and boom, I'm good to go. Next one. If we look 22, they are asking you these that have nuclear compositions, which are isotopes. Isotopes mean they have to be the same element. The atomic number is on the bottom, so automatically the atomic number should be the same. So like if you look at carbon 12, carbon 13, and carbon 14, the bottom is always the same. The mass number is always different. That's why X and Z represent isotopes. Next one. This is just simply a calculation of the average atomic mass. So remember, what you're going to do is you divide each of these by 100 to change them to decimals, because that's what we use. So you take the AMU, this value, times, this is going to be 0.9223. You're going to get a value there. I'm going to divide that by 100. I'm going to get 0.0467 times that value. I'm going to get another number there. I'm going to take this divided by 100. I'm going to get 0.031. Get that number. When you add all of them together, you get an average atomic mass, or a weighted average. That should be 28.0855 is your correct answer. So remember, when you go to set up a isotope problem, it's AMU times percent abundance plus AMU times percent abundance, etc., depending on how many isotopes. In this case, there's 3. If you look at the actual mass of silicon is 28, that tells you then that the majority has to be right around 28. You can see the abundance anyway there. You would see it on a graph. Same thing we talked about in class. Naming, you definitely need to know naming. MnSO4, memorization-wise, you know that's sulfate, but you also have to give it a Roman numeral because it is a transition metal. Next, whenever they ask you the percent abundance to solve, remember the setup we did in class? Pay attention, they're asking you for the percent abundance of each of the isotopes. So they're going to tell you what the average is. It says its atomic mass is 6.9409. So they're giving you its average atomic mass. They give you the actual masses of each isotope. You have that one and you have that one. So what you're going to do is you take those two masses. That's a real, hold on a second, highlighter. Take the mass there, take the mass there, and I drop them in. You know it has to equal 100%. So what you do is you make one x, you make the other one 1 minus x, and then you just use the distributive property to solve. Pay attention because this is the lighter one, this is the heavier one. So in this case, they wanted to know lithium 6, so I made that x. It doesn't matter which way where you put the x as long as you look to make sure what the question's asking you. Next, 26. They give you bromine as a element, liquid at room temperature, isotope, so it's isotope notation. So you know that number is the number of protons. So the number of protons, it says, which lists the atomic number. So the atomic number is 35, so you eliminate C, you eliminate D. The neutron number is going to be subtracting, so what you're doing is you're subtracting the mass number minus the atomic number, 46, and finally the mass number is 81. That's why A is the correct answer. 27 is weird. It says, which of the following statements about atoms and atomic subparticles is correct? This is incorrect because he did not use electrons. Rutherford used alpha particles. B is actually correct because we say the proton and the neutron have a mass of 1 AMU. Right? Let me change the ink. That's a little light. Neutron's mass is equal to that of a proton plus an electron. That is not true. We say the protons and neutrons are equal. An electron is much less. Neutral atom does contain the equal numbers of protons and electrons. That's why it's neutral. And a nucleus does not necessarily contain the same number of protons and neutrons. That's not true. So really in 27, both B and D would be true. Last one is a naming. It says sodium oxide, so you would look these up on the periodic table. Na, when you look up its charge, is +1. Oxide is -2. When you crisscross it, you get Na2O, and is an ionic compound because it contains a metal and a non-metal. All right?